20 feet east of a spotlight, here he is, walks north at a speed of 4 feet per second. The spotlight follows the man. How fast is the angle of the spotlight changing when the man has walked 16 feet? So let's take a look at what's happening. Here's our man, and he's walking. The spotlight's following him. The angle here is changing, and the man's position is changing. So what we're trying to figure out is if we freeze it right here, okay, a little farther, right, at 16 feet, how fast is this angle changing? All right, let's come over and figure out how to solve this. So the first thing is we need a function that relates this angle and the opposite side. So that's going to be our tangent function, and we'll draw a representation over here. The tangent of theta is y. We'll call this x. Well, now we need to know, well, what's changing? Well, again, let's look over here. What's changing? What's changing is the position of the man, so y is changing, and the angle's changing. But notice, since he's walking due north, x isn't changing at all. So the man is always 20 feet east of the spotlight. So we can rewrite this tangent equation as tangent of theta is y over 20. Now all of the variables are changing with respect to time, so we take the derivative of everything with respect to time. So the derivative of tangent is secant squared theta, but remember, theta is a function of time, so we have to multiply by theta prime. Y over 20 is just the same as 1/20th y, so the derivative is 1/20th y prime. So if we get theta prime by itself, theta prime is y prime over 20 secant squared theta. And since the secant is 1 over the cosine, this is the same as y prime times cosine squared of theta over 20. Now we fill in what we know. The man is walking north at 4 feet per second, so y prime is 4. At the point we're interested in, the man has walked 16 feet. So if we use the Pythagorean theorem, the hypotenuse is the square root of 20 squared plus 16 squared, so it's 25.6. Why do I need to know this? Well, I need to know what the cosine of theta is, and I'm going to write it as a ratio. Cosine is adjacent over hypotenuse, so it's 20 over 25.6. So if I square that, the cosine squared is 20 over 25.6 squared, which gives me 0.61. So if I come back to this equation right here, theta prime is equal to y prime, which is 4, cosine squared theta, which is 0.61, over 20 equals 0.122 radians per second.